Alright, so today you should have this sheet right here, uh, and we're going to be talking about potential energy. Now, so far to review, we've learned in this unit, we have talked about something called work so far, and we defined work by an equation of F times D, and that if work is done at an angle of any kind, we would add on, multiply that by the cosine of theta, the angle. So for work to be done, something has to move. If I'm just holding something up in my hand, it doesn't move, no work is being done, in physics terms that is. Alright, so this is an applied force. We're talking about the horizontal direction. If we're talking about picking something up, though, against gravity, there's another equation we can use. We can say work is equal to mgh, which is mass times gravity times height, which g is always equal to 9.8 meters per second squared. Now, if we're given a mass, say we were given, that something weighed 10 kilograms, and it was being picked up at a height of 3 meters, then we were working this out, we would plug that in 10 times 9.8 times 3 to figure out the work done against gravity. However, sometimes we're not given a mass, we're given a weight. Something maybe weighs 20 newtons and it's picked up 3 meters. Well, you could either plug it into the mgh equation, you'd have to find the mass, you'd have to take 20 divided by 9.8. Remember, your weight divided by 9.8 gives you your mass. Your mass times 9.8 gives you your weight. Or I could just look at this equation in another form. Remember, mgh. Remember, m times g is equal to fg, which is what 20 newtons is. Or we could write it as f, subscript w times height. And we plug that in, it would be 20 times 3 for a total of 60 joules of work being done in this case. So pay attention when you're given mass or you're given weight in the problem and how to address that. Well, that's going to lead us into today's lesson because we're talking about energy. We have two forms of energy. We have potential energy, which is stored energy, and then we have kinetic energy, which is energy in motion. And potential energy today, the equation we're going to use for that is mgh, the same as this equation right here because work and energy are related. Actually, the definition of energy is the ability of something to do work. So now back to this. You should have this handout right here. And first we're looking at potential energy. Potential energy is stored energy. And some different examples are we have, chemical energy that you see like in food. And then we'd also have elastic that you would see like in a spring or like a bow and arrow, rubber band. And then one other type is electrical. So you have like static charges that have potential energy. Now, in this class, we're going to focus on a certain type, we're going to call it gravitational potential energy. This is stored energy due to an object's position or its height. And this part, let's see. So remember that energy can be converted to different forms by doing work. That's how those are related. And gravitational energy is always measured from a fixed point. Let's say a fixed position. Always relative to the ground or relative to the table, whatever it tells you in the problem. So our equation is this. You can write it, I write potential energy a lot of times as like just PE equals, and the equation is mgh. Mass times gravity times height, or a lot of times it's written down, you'll see it like this, like E subscript P, same equation, mgh. Either way you want to write that. If you see me write it both ways, I'm bad to do it both ways. In this case, M is for mass, and it is in kilograms. G is acceleration due to gravity. And it's 9.8 meters per second squared. Always. We're talking about on Earth. And H is height. And it's measured in meters. Now the units for potential energy is going to be joules, just like it is for work. So potential energy, kinetic energy, work all have units of joules that we abbreviate with just with a J. So now let's look at some examples. And we have to pick out what the problem that we need and what we don't need. So ask me first, a 15 kilogram textbook is sitting on a 1.20 meter tall table. If the book is lifted 0.80 meters above the table, how much gravitational potential energy does it have? First with respect to the table. Well, to solve for this, I notice it gives me, some numbers it gives me in there. It gives me a mass of 15.0 kilograms. And it gives me it's sitting on, a 1.20 meter tall table. And if it's lifted 0.180 meters above the table, how much gravitational potential energy does it have? First with respect to the table. Well, my potential energy is equal to M times G times H. So when I'm solving for this, potential energy equals M is 15.0. G is always going to be 9.8. Then my height. If it's with respect to the table, and it's already sitting, the table is 1.20 meters from the ground, but it's sitting on the table. If you want it, it's lifted 0.8 above the table, so my first height is going to be 0.8. And to bring up my calculator, so that's 15 times 9.8 times 0.8 equals 117.6. And my units for potential energy are joules. Now, if this problem would have given me, instead of kilograms, say it would have given me 15 newtons, then I would have just had the 15 there, and I would have not multiplied the 9.8, because then I would use, P is, M times G is the same thing as force of gravity or weight. So we just said 15 times 0.8. You have to pay close attention to what you're given in the problem. Now I want to ask me, with respect to the floor. So again, my potential energy is equal to mgh. So potential energy is equal to 15.0 times 9.8 times, now how high was it from respect to the floor? Well, the table's already 1.20 meters tall, and then the book is lifted 0.8 meters above the table, so I have to add those two together. 1.2 plus 0.8 gives me 2.0, and then I multiply that out. 15 times 9.8 times 2.0, and I get 294 joules. So next problem. The potential energy of an apple is 6.0 joules. The apple is 3 meters high. What is the mass of the apple? So I'm going to start with my equation. I know potential energy is equal to mgh. So the potential energy is 6.0 joules. The apple is 3 meters high. So potential energy, I plug in 6.0 for that, equals my height is 3 times, mass would have been what I'm looking for, so I'm going to leave that as my unknown, m times 9.8 times my height, which is 3. Alright, so 9.8 times 3 is 29.4, so this gives me 6.0 equals 29.4 times m, divide both sides by 29.4, So I take 6 divided by 29.4, and I get 0.20 or 0.2. My mass, 0.2 kilograms. With the units. So again, if I put 6.0 equals my mass times, it's MGH, so that's 9.8. Height was 3. Let's check my math. Yeah, that's 6.0 divided by that. And I got 0.2. So my last problem here says what height is an object that has a mass of 50 kilograms if its gravitational potential energy is 9800 joules. So I know I'm dealing again with potential energy. Potential energy is equal to mass times G times H. My potential energy, it tells me, is 9800, so I'm going to plug that in for potential energy. Equals my mass, it told me is 50. I got G, so I have to put 9.8. And then my height is what I'm looking for. Let's just leave that as H. So say 50 times 9.8 equals 490. So it's going to leave me with 9800 equals 490 times H. Divide both sides by 490. So that gives me an answer of 20. And my units for height are going to be meters. So that would have been my answer now. Like again, one more time. If I'm given a mass in this problem, I'm going to use this form of the equation. If I'm given something like a weight, say if I was given this and it said 75 newtons, I'm given a weight, then my equation becomes this. P equals, remember mg is equal to your force of gravity or your weight, so it would just be F of g times the height. You wouldn't have had to multiply, by 9.8. You would just plug that in as 75 times the height, or found the height of it. So just be careful about that.